Welcome back. Today we're going to discuss in-database machine learning with MemSQL Helios and AWS SageMaker. Many of today's modern data challenges introduce the need for both batch data as well as live data. In MemSQL Helios, you can easily bring in those various different types of data through MemSQL pipelines. Say you're bringing batch data from an existing database like SQL Server or an object store like S3. And then you'd like to bring in your live data from sources like Kafka and other IoT streams. Once that data is in Helios, you're able to do many different machine learning operations, all the way from exploratory data analysis to feature engineering and model training and model creation. When it comes to executing those models, having access to live data enables you to score those models in real time and then even retrain them to make sure that you're always getting the most accurate results. From a user experience standpoint, this could be done either in MemSQL Studio with various different machine learning options that you have within the database itself, or it can be done with the tool of your choice, like AWS SageMaker, like we'll discuss today, TensorFlow, or Azure ML. You can then use visualizations in platforms like Looker, Tableau, Power BI, etc. And if you'd like, you can even take the inferencing that you're doing within MemSQL Helios and select those inferences out into a downstream Kafka topic. What that enables you to do is then create downstream decisioning within your operational applications. When it comes to AI and machine learning for MemSQL Helios, we're really enabling everybody within the data ecosystem, all the way from data analysts to data engineers, citizen data scientists, and data scientists. For data analysts, we're accelerating dashboards with seamless connectivity into Tableau, Power BI, Looker, etc. For data engineers, we have features like our Spark connector that enables users that are doing data movement or analytics through Spark to increase their productivity by 20x. For citizen data scientists, we have a multitude of machine learning functions within the database itself. And then you're able to then manage those versions of all your models within this database infrastructure. For data scientists, like we'll be discussing today, you can leverage your models in place using SAS, Python, SageMaker, and execute those models in the database itself. So let's now talk a little bit about how MemSQL Helios accelerates AWS SageMaker. So what you'll see today is our ability to leverage SageMaker with data sitting in S3 to build a supervised learning model. You'll then push that model into MemSQL Helios, and that model is then saved as a user-defined function within the database. We'll wrap up today's discussion by executing that model in real time against a live feed of data coming from Apache Kafka. Let's dive in. So what I'm going to start by doing is going into portal.memsql.com, where I can launch a fully managed MemSQL Helios cluster. I'm just going to go to the top right here and say create cluster, and I will say SageMaker modeling cluster. And this will be a development cluster, and I'm just going to say this is going to be for machine learning, AI, and analytics. So here you have the option for a free trial or on demand. Since I've already used my free trial, I'm going to go on demand. And I'm going to launch this in AWS Northern Virginia 1. I can select my cluster size here, and you see that we have all the way from our H0 cluster to H16 cluster with varying amounts of vCPUs, RAM, and disk. I'm just going to start by launching an H2 cluster, which will give me plenty to do my SageMaker operations today. I'll hit next and then create a password. And for now, I'm just going to allow access from anywhere, though this is not recommended. I'll go ahead and create my cluster. And now this cluster will launch. Great. It looks like our cluster is completely launched, and now we can look at its properties that we configured earlier. We have an H2 size cluster in Helios, deployed in AWS Northern Virginia 1, on the latest version of MemSQL. We can connect to our cluster using MemSQL Studio or our admin endpoint or client endpoint. The admin endpoint is going to be for your alters, creates, drops, statements, etc. And the client endpoint is going to be for more of your inserts, selects, and updates. We can hop into MemSQL Studio here, and you have your SQL editor where you can create your databases, define your schemas, and run some queries to test. You also have dashboard within MemSQL Studio here that tells you how many databases you have, your pipelines, and a little bit about your data within your cluster. Now, for this example, let's jump into a Jupyter Notebook to interact with both AWS SageMaker, S3, as well as our MemSQL Helios database. All right, so to start, we're going to train a simple xgboost model and deploy it as a UDF within MemSQL. I'm going to just bring in some data that AWS SageMaker uses within their tutorials, which is really a bank churn data set to analyze customer behavior. We're then going to split this data as 80% training set and 20% test set. And now you'll see that I have 80% of my data in my train set, and then the other 20 in test. I'm going to convert this pandas data frame now to a NumPy matrix, just so we can use it in our xgboost model. Now I can train this model using an xgboost classifier, and I'll inspect the model now. Everything looks good so far. But it's kind of hard to read the model without the feature names, so let's go ahead and add those in. And you'll see we have our feature names as well within our model, within our Jupyter Notebook. Now I'm going to connect into MemSQL Helios. So using our MemSQL Python library, what we're going to do is give the host name here for our master aggregator within MemSQL Helios, which is going to allow us to create a database, use that database, and do various different things within it. So I'm going to create a database and then use it within Helios. So now that this operation is complete, let's jump back into MemSQL Studio and see if that database is there. You can see now that the database we just created within our Jupyter Notebook is available for us to use as test SM within MemSQL Studio. Now it's time to deploy this model to our MemSQL Helios cluster. So this first operation is going to take that xgboost model and use a library that we have available on GitHub to convert models in xgboost to a Helios UDF. And now we can use a show functions command that tells the database to show the user defined functions that we have within this database. And you can see that we have our apply trees function and then a number of different trees that are all UDFs that come directly from that xgboost model. We could also do that same command here in MemSQL Helios Studio. I see all of my functions now as trees that were defined by admin. So now that the model is loaded, let's go ahead and load some data into a table in my MemSQL Helios database. Now what we can do is select a few rows of data within the database to predict from. Now we'll apply this user-defined function using its name, apply trees. So we'll just do select apply trees, and then all of the column names are going to go within the select statement. And this will use the UDF, which is based off of the xgboost model within the database to get us predictions. And now we can see a small subset of our predictions here, which are likelihood of churn within our customer set from our bank. We can then compare these results to the xgboost model predictions that we had from before. And you can see that they're quite similar. We can also just go ahead and take a look at our data within the database. So you'll see I have customer ID, age, campaign, and various other features that have been used in my xgboost model. Great. Now that we have trained an xgboost model and deployed it within the database as a user-defined function, now let's talk about how we can train an xgboost model on AWS SageMaker and then deploy it to MemSQL. I'm going to start by just importing some Python libraries to this Jupyter notebook again. Some of these are MemSQL libraries, and some are just standard xgboost, SageMaker, etc. I am then going to carefully put in my access secret, session token, and other parameters to make sure that I'm able to authenticate against S3 as well as SageMaker using my credentials. I will then start a session. And you can see that I've created an S3 bucket successfully. But just to make sure, let's go ahead and go into S3 and see if that bucket's there. You can see here that I have S3 buckets from this example that were made, and I have one from today as well. Now you'll find that this S3 bucket is currently empty. Let's populate it with some data. So I'm going to just start by prepping this data that I have for learning. I'm going to bring in that same bank churn data set into my data frame. And I'm going to add in the features. You can see all of my features here. I'm going to split that data. And then I'm going to do an operation to load this data into my S3 bucket. You can see that it's been successful and my S3 bucket has been populated with this data. I have it all in my train set here, and I have train.csv. Now let's actually train our model. This is where SageMaker comes into play. So within SageMaker, I'm going to use my SageMaker estimator for xgboost. I have to specify the container, the role, the instance count that I'm going to use for my training, and even what type of instance I want to use to train. Great, it looks like our model has finished training. You can see that it took about 85 seconds to train this model using SageMaker. Now, let's connect in our MemSQL Helios cluster. First, we need to create our database and use it. And then we're going to just take xgb.model_data, which comes directly from the model that we built in SageMaker. And you can see it points directly at this S3 bucket containing the model.tar.gz file. If we go back into S3, we'll even see it here in models. Now, we can also go into SageMaker and see that we have a few completed training jobs here one that completed just now. So now that that's complete, this is going to be our critical line to make sure that we take that same xgboost model and deploy it into MemSQL. It'll take the model data itself, the features, the MemSQL connection, and the feature names to deploy this. Great. So now let's go ahead and just reload that data within the MemSQL Helios. And we are going to run this model again within our data in Helios. You can see that I have loaded this xgboost model from S3, and I have my model here, and I can just run predict to get my predictions. I can also then run my user-defined function called apply trees that represents this xgboost model and get all of my predictions here. If we just want to go ahead again and see that we have our functions, we have even more trees now, which represents all of the new xgboost, the new function, that new xgboost function that came into the database. Now let's jump into how we can ingest data from Kafka and run a classifier against that data. We're going to use the same data set again with from the bank churn. And a lot of these steps are the same to convert the pandas data frame to the NumPy matrix, training the model again, connecting to Helios, deploying the model, and then loading data into that table. Now what we're going to do is utilize a function in MemSQL called select into Kafka. What we're essentially going to do here is take data that sits in this table and dump it into a Kafka topic, which we will then re-ingest for predictions. You can see that we have a number of examples here. You can see that we're just going to start by identifying a Kafka endpoint here and selecting star from our entire bank table into the Kafka endpoint. Now we're going to load the data from the Kafka topic into MemSQL using Kafka pipelines. And what we're also going to do is compute the user-defined function, which is that xgboost model, inside of a stored procedure. So let's just walk through what we're doing here. We're dropping our table, if it exists, called res. And then we're creating this table, which will show us the expected value of our prediction and then the actual predicted value. Now, what our stored procedure here is going to do is process data that's coming in from Kafka and then insert into our table called expected with the fields expected and predicted, but then also apply this user-defined function, which is that xgboost model, against every data point that's coming in through Kafka. Let's go ahead and start this. And we can see that this procedure has been created, and we've also started this pipeline of Kafka data. Let's go see if this pipeline has actually been created. Fantastic. You can see that we have a Kafka pipeline created in MemSQL Studio, all from a Jupyter notebook. And this process Kafka data is going to be bringing in live data points to execute against that xgboost model. Now the Kafka data will start loading and we can see a few rows of our result. Awesome. So the first 5 rows of our result set here that are coming in through Kafka, again, this is all live data. We can see that our expected value is 1, and the likelihood of this occurring is 0.029. You have various different other predictions that are coming in through and that will be scored live using Kafka and this xgboost model that we brought in into MemSQL Helios. Great. Now what we're going to do is show you a big data example of this using a TPCH dataset. Again, we're going to connect into the same MemSQL Helios cluster, establish our connection. Now what we're going to do is bring data from Amazon S3. So we're just going to create our line item table here, which has data such as order keys, part keys, line item, numbers, quantities of orders, their prices, etc. And we're going to create a pipeline to S3 that's going to point directly at an S3 bucket to bring all of this data in. Great. Let's jump back into MemSQL Studio to check out that pipeline. Fantastic. You can see we have 2 pipelines now, and we can go view them. So the original pipeline we had was our process Kafka data that's doing the scoring against the previous xgboost model that we built. And now we have our TPCH 100 line item pipeline that is going to bring in data from S3. And so as this data is being brought in from S3, we can even do things like check out this line item table within MemSQL Studio. All I have to do here is come in and say select star from line item and run that. And you can see that I now have data coming in from my S3 bucket. Let's see how much data's come in. Wow, fantastic. So we see we have about 85 million records that have just come in to our line item table. So now let's load a small part of that data from Helios and prepare it for training. So I'm going to use some feature columns such as part key, supply key, quantity, discount, and tax, and then my prediction column will be my price. I'm just going to select about 50,000 of those records and bring them into a data frame. You can see that here. I'll now split this into training and testing data and just print out how many rows are in each. So 40,000 and 1,000. Let's go ahead and train this model again and deploy it to MemSQL. And now that this model has been deployed to MemSQL, let's have a little bit of fun. If you'd like, you can also go through the rest of this notebook to try some very interesting queries related to mean squared error. This query here will compute a UDF on a lot of rows and compute the mean squared error on this specific trees function that we have created. You can then get predictions for 5 rows, get the 5 best predictions, 5 worst predictions, etc. I hope you've enjoyed this discussion on deploying supervised learning models into MemSQL Helios. I hope you get a chance to try it. Thanks.